Metallic bonds. Recall, metals form positive ions, cations, due to their weak hold on their valence electrons. Consequently, metal cations will be surrounded by a sea of delocalized electrons. So this animation here, we have the metal cations, which are the little purple spheres, and the little cloud that's moving around are the negative electrons. So that's what we refer to as a sea of electrons. They are freely moving between the metal cations. So specifically, a metallic bond is the electrostatic attraction between a lattice of metallic cations and the sea of delocalized electrons. Remember, electrostatic refers to the positive and negative charge, refers to positive and negative charges. Opposite charges attract one another. So this would be a nice little diagram. You have the sea of electrons, the little blue dots here, immersed within the metallic cation crystal lattice. Note that metallic bonding is quite different than ionic bonding. So ionic bonds, you have alternating positive and negative charges. We have cation and an anion. So quite different from a metallic bond. For a metallic bond, we only have metallic cations, and immersed between those cations are electrons. And those electrons are delocalized. Those are what make up the sea of electrons. They're free flowing. They can move around. Properties of metals. They're good conductors of heat and electricity. I'll show you a little video clip.
Free flow of electrons explains the ability of metals to conduct heat and electricity. When you heat up a metal, the free electrons quickly start vibrating. Increased kinetic energy means increased temperature. When an electric current is applied to a metal, electrons enter from one side, causing repulsion and generating movement within the sea of electrons, and an equal number of electrons exit the metal as the number that entered.
And that is what we mean by electricity, the flow of electrons. So the electrons are easily able to flow through a metal. Malleable, which means it can be hammered into sheets. Another video clip.
Metals are able to deform in response to an applied force. The mobile sea of electrons shields the cations from each other.
So you can just wallop on a piece of metal and it's not going to break because the metallic cations can just move around. The electrons, think of the electrons as kind of a glue that holds everything together, and that glue has fluidity. It can move around. Ductile, which means it can be drawn into wires. Another video clip.
D. Ionic compounds are not ductile for the same reason they are not malleable in general. If an ionic compound is forced into a long cylinder, it breaks apart because of the repulsion of like ions. In contrast, a metal can be pulled into a long cylindrical shape because the cations can line up, shielded from each other as the fluid-like sea of electrons flows around them.
Okay, so those are the three properties you need to know for metals. And last, alloys. Alloys are a mixture of metals, sometimes non-metals as well. I like to think that a good analogy for alloys is if ever as a child you were traumatized by having your box of crayons out in the sun melt. So you have all those colors melt together, and then it rehardens, and you have a crayon alloy. But for metals, it's the same thing. You take a metal, heat it up so that it's melted, and then different metals, and then just pour them together, and then let them cool off, and you have a alloy. Here are some common alloys you've probably heard of. Brass is a mixture of copper and zinc. Now, there's no specific ratio. It just contains copper and zinc. So there's different proportions of copper and zinc in different types of brass. Bronze is the same thing, copper and tin. Steel is iron and carbon. Carbon's a non-metal, but it's still referred to as an alloy. Sterling silver is a mixture of silver and copper. White gold. It used to be real popular in ancient times. We used it for all kinds of things, mass, coins. It's a mixture of gold and silver. Amalgam, which can be used for fillings, teeth fillings, tooth fillings, which contains mercury, silver, and another metal, or another metal like gold. Okay, that is it. That is not just the end of the notes. That is the end of Unit 3.